Hello. And thanks for watching this presentation. This publication is a continuation of the Asteroid Polynomials 1 publication. Here we will try to get a deeper look into the header area of the value space of this sequence, showing videos which have been created for this area with the Asteroid polynomial sequence. The first video shows the evolution of the Asteroid polynomial sequence in the header area, starting from index 6 and ending at index 28. It is a flat contour map representation and it applies a zoom factor of 50. Please pay special attention to the areas which keep nearly fixed their form and extension, and which are being surrounded step by what we call fortification rings. Each fortification ring consists of a deep valley, painted in the blue color range, and a very high mountain wall, painted in the beige to white color range. With each step of the polynomial sequence, the valleys and walls of the fortification rings become deeper, higher, and smaller, so that finally we are just not able to distinguish the different rings. This video is a continuation of the last one. It takes a closer look to part of the header area. Also is a flat contour map representation and it applies a zoom factor of 100 and runs between index 6 and 25 of the Asteroid polynomial sequence. Please pay special attention to the nearly fixed areas which we saw in the last video and the now visible bunkers and the highway which connects all these special areas. This video takes an even closer look to the header area. The video is also a flat contour map representation, and it applies a zoom factor of 300 and it runs between index 15 and 22 of the Asteroid polynomial sequence. Please pay special attention how this video shows the evolution to an aerial view of a big city, with perfect designed districts, streets, parks, and lakes and so on. Let us look now how the header area is constructed. To do so we use 3D spatial representations. The first video has nearly the same parameters than the previous one. It applies also a zoom factor of 300 and it runs between index 6 and 25 of the Asteroid polynomial sequence. To increase the contrast in this and the following videos, we use a slightly different coloring concept. Normal landmass pixels are painted using a dark blue color range. Ocean parts are painted using a dark red color range. This video goes even closer to the interesting parts of the header area. It applies a zoom factor of 1000 and it runs between index 10 and 27 of the asteroid polynomial sequence. It shows in a very clear way how the bunkers and the fortification rings are constructed. This video goes even more closer to the bunkers of the header area. It applies a zoom factor of 10,000 and it runs between index 11 and 25 of the asteroid polynomial sequence. This video gives a detailed look of the nearly fixed objects in the header area. It applies a zoom factor of 400,000 and it runs between index 71 and 86 of the asteroid polynomial sequence. Please pay special attention to the self-similarity of these nearly fixed objects with the entire asteroid object and also to the fluttering equals up and down movements of these objects. As we saw in the videos of this presentation, the asteroid polynomials contains a lot of interesting structures, with sometimes very mysterious evolutions. To understand a little bit better these evolutions, we need to analyze more details of the harbor area with its strange missile launchers and elevation platforms which we can find in this area. This analysis will be presented in the Asteroid Polynomials 3 publication.